Now we're going to consider what happens to bulb B when you close the switch. So same circuit, switch opened, maybe you have some light, switch closes, maybe you have a different amount of light. All right, so let's start the initial open. Here we go. We got to think about the current in bulb B. So it's actually the total current. Remember before we talked about I total. Well, whatever total current comes out of here, has to go through here to come back. So what we need to start out with is the total EMF that the battery puts out. Or sorry, the EMF the battery puts out is the current it puts out times, it doesn't know what's going on, just the equivalent resistance. And then that I total, we don't have to divide it up because the bulb we're thinking about isn't in a branched region. You know, if we needed the current in that bulb, we would have to think about how it divides and everything. But here, it's just I total. All right, so let's do that. Let's then say that I total that we care about is the EMF, the EMF over R. And what R equivalent? R equivalent is R plus whatever this is plus R. So we could say R plus, let's see, this branch, when it's open before we said was 3/2 or 2/3? 2/3. 2/3 R. Plus R. That last R is B. Okay. Just to be clear, I'll put a little B here. That makes sense. Okay, so then we just say, okay, let's just solve for that and get in terms of the E, the EMF and the value of R. Let's simplify it down to that and see what is this. This is 2/3, 3/3, 3/3, 3/3, 3, 6, 9, 10, 11. 11/3 R, or we take it up top and say 11 over 3R. There's your 11/3 R. All right, so that's the current going through bulb B, and the light would be proportional to the square of that current. But we really just need to know, does the current go up or down? If the current goes up, the square will go up. If the current goes down, the square will go down. Okay, so now let's do final closed. All right, here we go. The EMF, same story. EMF is I total R equivalent. It's the same situation. Open this or close, it doesn't matter. The total current through the circuit is going to go through bulb B. All right, so the I total is the EMF over R equivalent for the thing closed. Okay, R plus R plus, what is the branch? The branch, when it was closed, was 0, because we shorted all these bulbs out, plus 0, plus the last thing in series, R, which is due to B. Is it B? What is that? That looks to me like 3R on the bottom, EMF over 3R. Is that correct? Yes. Why does one have an 11? Hold on. Oh yeah, no, I have one of these wrong. Whoops, okay, yeah. So you probably noticed, we're very, I did this on purpose. I'm just checking if you're good at your math. Yeah. So this is 3 plus 3 plus 3 plus 2 is 11. The 11 is here. Of course, yes, and the 3 is here. There we go. Because I knew it comes out at least close, right? Okay, so 3/11 is 0.27, 0.27, 0.27, 0.27, and 1/3 is 0.333333. So this is higher current. 0.33 E over R, and this is 0.27 E over R. So this wins, so it gets brighter. That's the story. The current is higher here, so it gets brighter. You get light in both cases, but you get more light down here. Because basically you've taken some resistors out of the circuit. If you take resistors out of the circuit, when they were in series, resistance goes down, total resistance goes down, so the current goes up.